So we're going to pick up where we left off on the notes from last time. So these are the 5.2 notes. And we finished up example B, and now we're going to look at some information beyond that. So if we take a look here, the equations we worked on in example B are versions of the general exponential function, which we looked at in 5.1. Looks like y equals a times b to the x. And notice that x is the exponent in this equation. So that's our form, and x is up in the exponent. The general power function is something slightly different than the general exponential function. So again, in the exponential function, the x is what's in the exponent. In a power function, we have an exponent, but x itself is not the exponent. So the general power function looks like this. Y equals a times x raised to the n. So notice that in the power function, the x is serving as a base, not serving as the exponent. And when we fill in a power function, the a will be replaced with a number, and the n will also be replaced with a number, and the variables will be the y that's out in front, and then the x that's serving as the base. We solve power functions differently than we solve exponential functions. So here's the kind of the strategy. We'll look at it here in example C. So we're going to solve each equation using rational exponents. And you've heard of rational numbers, and rational numbers are just numbers that can be written as a fraction. You can see the word ratio, right, is within the word rational, and ratio is really just another way of saying a fraction. So rational exponents are just exponents that can be written as fractions. So in examples 1 through 3, we're going to solve some power functions or power equations, and we're going to do that by using rational exponents. So if we look at number 1, we have a power equation. It's a power equation because we have a power, we have an exponent. The 4 is the exponent. We wouldn't call this exponential because the x isn't up in the exponent, the x is serving as the base. So we call this a power equation. So what we have to do is get x by itself, and the way we're going to do that is to get rid of the power of 4. Now if we had something like x squared equals 16, we could get rid of that power of 2 by square rooting both sides. But at this point, we haven't talked about how to get rid of a power of 4. And we're not going to square root both sides to do it. Square rooting both sides only works if we want to get rid of a power of 2. So the way to get rid of the power of 4 is actually to raise this whole thing to the reciprocal of 4. And 4 is the same thing as 4 over 1, and the reciprocal of 4 over 1 is 1 over 4. So if we do it to one side, we have to do it to the other side. So we're going to raise both sides to the 1/4 power. And if you take a look at what happens, 4 times 1/4, 4 times 1/4 is just 4 over 4, which is just 1, and x to the first is just x. So we raise to the reciprocal to make the powers or exponents kind of cancel out and become just x to the first or plain x. And then 3,000 to the 1/4 is something we can do in our calculator. So we can go to our calculator, we can type in 3,000 raised to the 1/4. I'm going to put that in parentheses. If you want to do 3,000 raised to the 0.25, you could do that as well. And we get an answer here. It's not a very pretty answer. It's about 7.4. So we can say that x is approximately equal to 7.4. So to solve a power equation, we can raise both sides to the reciprocal of the given power to eliminate it. Let's look at the next one. The next one here, we have an x raised to the 2.5. So we'll deal with getting rid of that 2.5 in a moment. But the first thing we should do when we look at power equations is we want to remember all the other good solving strategies we already know. So we already know that to make number 2 look simpler and to get x closer to being by itself, we can get rid of the 6 in front by dividing. So we're going to divide both sides by 6. The 6's cancel, and we're left with a simpler looking power equation. x to the 2.5 equals, well, 90 divided by 6 is just equal to 15. Now we're in that kind of simple form where we have the base being x raised to an exponent equals something else. So now to get rid of that power of 2.5, again, square rooting both sides only works if we had x squared. We have x to the 2.5. So the way that we're going to get rid of it is to raise both sides of our equation to the reciprocal of 2.5. You could go through changing 2.5 to an improper fraction and then flip the fraction to get the reciprocal. The easier way is that if we just have 2.5, we can raise both sides to the 1 over 2.5. Now I know that 1 over 2.5 is really not a fraction that's allowed because there's a decimal attached with it, but we're going to go ahead and use it anyway. It's not our final answer, so I'm not worried about the fact that we're using this kind of fraction that's not typically allowed. So 2.5 times 1 over 2.5, because that's what we have here. We have a power raised to another power, and our exponent rules would tell us to multiply those. So 2.5 times 1 over 2.5 is just gone. It's x to the first, or just plain x. And then 15 raised to the 1 over 2.5 we'll do on our calculator. 15 raised to the parentheses 1 over 2.5, close parentheses. And your calculator might look a little different if you have an older operating system than the calculator I have. That's why I'm putting the parentheses in. Make sure you do that. And our answer is about 2.95. And we get x approximately equal to 2.95. If you wanted to check your answer, you certainly could. You could take that 2.95, put it in place of x, take 2.95 and raise it to the 2.5 power on your calculator, and multiply by 6. We should get something right around 90. It might not be exactly 90 due to the rounding that we did, because rounding error can play a big role. Finally, our last problem here. Again, don't forget about all the old equation solving skills you have. So for number 3, we want to make things look as simple as we can and get x almost by itself before we raise both sides to something. So clearly here, to get rid of that plus 5, we can do a minus 5 on both sides. And we're left with 7x to the 1/3 equals 42. Finally, before we raise both sides to something, we can get rid of that 7 hanging out in front by dividing by 7. We get x to the 1/3 equals 42 divided by 7 is 6. Finally, we've kind of done everything we can. The x is totally by itself except for this power, this exponent that we don't want anymore. So we'll raise both sides to the reciprocal of the exponent. The reciprocal of 1/3 is just 3, or 3 over 1. We'll raise both sides to the 3rd power. Again, the exponent rules tell us that we would take the 1/3 and multiply it by 3 to make this look simpler. And 1/3 times 3 is just 1. So we have x to the 1st, or just x. 6 to the 3rd power. Let's see, 6 times 6 is 36. 36 times 6 again is 216.